January 1944. 30,000 feet above central Germany. The sky is a hard, empty blue, stripped of warmth and sound. At this altitude, the temperature hovers near minus 40 degrees Celsius. Metal stiffens. Breath freezes. Human skin begins to fail within minutes. Inside the cramped cockpit of a German Messerschmitt Bf 109, a pilot fights more than gravity and enemy fire. His gloves are thick, but the cold pushes through them anyway. His fingers ache as they move across metal switches that feel like ice. The oxygen mask presses tightly against his face, each breath dry and thin. Frost creeps along the edges of the canopy. Ahead, contrails cut the sky in clean white lines. American fighters. They are high, higher than expected, and they are not diving away. They are holding position, steady and composed, escorting bombers deep into the Reich. What unsettles the German pilot is not just their altitude. It is their stillness, their precision, their apparent comfort in a place where human beings are not meant to linger. In the frozen silence of the upper air, a quiet realization begins to form. The Americans are not merely surviving the cold. They have learned how to master it, and that advantage, invisible from the ground, is about to reshape the air war over Europe. The reason for that difference begins far from the front lines, in how this war in the sky was first imagined. Before the skies over Europe became a frozen battlefield, air combat was imagined very differently. In the early 1930s, most military planners believed wars would be decided quickly. Aircraft were designed for short missions, limited ranges, and brief engagements. The idea that fighters would spend hours at extreme altitude, exposed to lethal cold, was not yet central to aviation doctrine. This assumption shaped how cockpits were built, how pilots were equipped, and how nations prepared for war in the air. The German Luftwaffe emerged from this mindset. Rebuilt rapidly after 1935, it was designed for speed, shock, and close coordination with ground forces. Fighters like the Messerschmitt Bf 109 were superb machines, fast, agile, and deadly in combat. But they were optimized for European distances and short interception missions. Cockpits were compact and lightly insulated. Heating systems, when present, were limited and often unreliable at extreme altitude. German pilots felt this immediately once the war expanded vertically. At 25,000 feet and above, the environment itself became an enemy. Temperatures could plunge below minus 30 degrees Celsius. Oxygen grew thin, reducing concentration and reaction time. Metal controls stiffened. Lubricants thickened. Condensation froze along canopy frames, obscuring vision. Even brief exposure could lead to frostbite or hypoxia. The Luftwaffe attempted to compensate. Heavy flight suits were introduced. Electrically heated gloves were tested. But power supplies were inconsistent. Oxygen systems existed. But early designs were prone to freezing or malfunctioning under sustained cold. The cockpit, however, remained largely unheated. Weight and complexity were seen as liabilities in fighters that prized climb rate and maneuverability. Early in the war, this was not yet catastrophic. Over Poland and France, most air combat occurred at lower altitudes. Missions were short. German pilots could endure discomfort long enough to fight and return. The system appeared sufficient. That illusion began to break in 1940. The Battle of Britain forced sustained high-altitude operations. German fighters climbing to meet RAF bombers and Spitfires encountered cold they had not fully prepared for. Pilots reported numb hands, fog canopies, and exhaustion after long sorties. Still, the Luftwaffe pressed on, believing skill and aggression could overcome physical strain. Across the Channel, the British were learning similar lessons. The Royal Air Force had already begun addressing altitude challenges through better oxygen systems and cockpit heating in some aircraft. But it was the entry of a new air power that would push these problems to their limits. When the United States entered the war in December 1941, it brought with it a radically different scale of ambition. American air planners did not envision short, sharp battles. They planned for long-range strategic bombing, missions that would last hours, not minutes, and would operate at altitudes where cold could kill as surely as enemy fire. This shift would force a fundamental reevaluation of what a fighter cockpit needed to be. Not merely a seat and a gun platform, but a survivable workspace in one of the harshest environments on Earth. That transformation did not happen overnight. It was shaped by doctrine, industry, and painful early experience, elements that define how America prepared for a very different kind of air war. And it was in that preparation that the true divide between the two air forces began to emerge. When the United States committed itself to the air war over Europe, it did so with a strategic vision that demanded endurance as much as firepower. American planners believed daylight precision bombing could cripple Germany's industrial heart. To do that, heavy bombers like the B-17 Flying Fortress and the B-24 Liberator would have to fly deep into enemy territory, often at altitudes above 25,000 feet. These were not quick raids. Crews could remain airborne for 8 hours or more, exposed to constant cold, vibration, and fatigue. From the beginning, American aviation medicine and engineering were tightly linked to this mission. The U.S. Army Air Forces recognized early that high-altitude flight was as much a physiological challenge as a mechanical one. At extreme altitude, oxygen deprivation impaired judgment. Prolonged cold reduced dexterity and slowed reaction times. Fatigue accumulated long before enemy fighters appeared. If crews could not function effectively, even the most advanced aircraft would fail. Unlike Germany, the United States possessed vast industrial capacity and the freedom to prioritize pilot survival and comfort without sacrificing production speed. American designers could afford weight increases if they translated into operational reliability. Comfort was not seen as indulgence. It was seen as combat effectiveness. Heated flight suits were introduced and steadily improved. Electrically heated gloves, boots, and vests became standard issue for bomber and fighter crews operating at altitude. Oxygen systems were refined to deliver steady flow even in extreme cold, reducing the risk of hypoxia during long missions. Cockpit insulation was improved, and heating systems were engineered to distribute warmth more evenly. Fighters, too, were reimagined. The P-38 Lightning, designed with high-altitude performance in mind, featured cockpit heating and turbo supercharging that allowed it to operate effectively where earlier fighters struggled. The P-47 Thunderbolt, massive by fighter standards, carried a powerful turbocharger that excelled at altitude. Its cockpit, while not luxurious, offered better insulation and heating than most German counterparts. Later, the P-51 Mustang combined range, speed, and altitude performance into a design that could escort bombers deep into Germany and stay with them. These aircraft were not perfect. Early heating systems sometimes failed. Oxygen masks could frost. Cold still found its way into every seam. But the difference lay in consistency. American systems were designed to function for hours, not minutes. Maintenance crews were trained to service them. Spare parts were available in abundance. As U.S. fighters began escorting bombers beyond the limits of German radar coverage and interception timing, the air war changed character. Engagements grew longer. Altitudes increased. Pilots were required to maintain vigilance for extended periods in conditions that punished even minor weaknesses. German pilots noticed the change almost immediately. Where earlier American fighters had turned back or descended, new escorts held altitude. They remained above the bombers, conserving energy, waiting. Interceptions that once relied on surprise now faced opponents who arrived already alert, already positioned, already functioning at full capacity. The advantage was subtle but relentless. It was not a single innovation, but a system. Engineering, medicine, logistics, and doctrine working together. And as winter missions multiplied, that system began to reveal its true power, not through dramatic moments, but through steady dominance in the cold, thin air where the war was increasingly decided. The consequences of that difference would be felt not just in machines, but in the bodies and minds of the men who flew them. Angle 1, the human body as a battlefield. At 30,000 feet, combat begins long before an enemy aircraft appears. For pilots on both sides, the physical strain of high-altitude flight was constant and unforgiving. Cold reduced blood flow to fingers and toes, slowing reaction times at moments when seconds mattered. Oxygen deprivation dulled concentration, making complex tasks, navigation, formation flying, target identification, more difficult with every passing minute. German pilots often entered combat already fatigued. Interception missions demanded rapid climbs, which consumed oxygen and energy. Once at altitude, they were expected to fight immediately, sometimes after struggling with frozen controls or fog canopies. Reports from Luftwaffe units described numb hands, aching joints, and difficulty maintaining focus during prolonged engagements. American pilots faced the same environment, but their experience was often different. Heated clothing reduced the shock of exposure. Cockpit heating, even if imperfect, slowed the numbing effects of cold. Improved oxygen systems helped maintain mental clarity during long escort missions. The result was not comfort in a civilian sense, but functionality. Pilots who could still think clearly after hours in the air. This endurance mattered. A pilot who could stay alert longer could spot threats sooner, react faster, and make fewer mistakes under stress. Over time, these small advantages accumulated into survival and success. Angle 2. Cockpit heating as combat technology. Cockpit heating was not glamorous. It did not increase speed or firepower, but it transformed how long a fighter could remain effective at altitude. American aircraft routed warm air from engine systems into the cockpit, moderating temperatures enough to prevent extreme cold from overwhelming the pilot. Insulation around the cockpit reduced heat loss. Electrical systems supported heated flight gear, ensuring hands and feet remained usable even in prolonged engagements. In contrast, many German fighters relied primarily on pilot clothing to combat the cold. Heating systems, where present, were often limited in output and reliability. Electrical capacity was constrained, and cockpit space left little room for additional insulation. German pilots quickly learned the consequences. Frozen oxygen lines, stiffened control cables, and reduced dexterity were common complaints. In winter, missions could become tests of endurance rather than skill. The difference was not dramatic in any single encounter, but over months of sustained operations, it reshaped the balance of the air war. Angle 3, medicine, training, and preparation. Behind American cockpit design stood an expanding field of aviation medicine. U.S. researchers studied hypoxia, cold exposure, and fatigue, translating findings into equipment and training. Pilots were taught to recognize symptoms of oxygen deprivation and cold stress. Equipment was adjusted based on feedback from the field. This institutional response stood in contrast to Germany's increasingly strained system. As experienced pilots were lost, replacements arrived with less training time and fewer hours at altitude. Equipment shortages limited upgrades. Adaptation became slower as resources dwindled. By the winter of 1943, the gap was no longer theoretical. It was visible in mission outcomes, pilot survival rates, and the growing confidence of American air crews operating high above enemy territory. Yet to German pilots, the most striking realization was not found in reports or statistics, but in direct encounters with enemy fighters that seemed unaffected by the very conditions meant to stop them. Angle 4. The enemy's view from the cockpit. For German pilots, the difference became impossible to ignore during sustained encounters. Intercepting American formations in late 1943 and 1944 often meant climbing rapidly to extreme altitude, expending energy before combat even began. By the time Luftwaffe fighters reached bomber streams, American escorts were already waiting, circling above, engine steady, pilots alert. German after-action reports increasingly reference physical strain rather than tactical failure. Pilots described hands stiff with cold, difficulty adjusting gun sights, and fatigue setting in before the first shots were fired. In contrast, American fighters remained on station for long periods, maintaining altitude and formation discipline. What unsettled German pilots most was the sense that their opponents were operating on a different timetable. American fighters did not rush. They did not descend early to escape the cold. They stayed. That endurance suggested preparation, equipment, and support beyond what Germany could now match. Angle 5, leadership and design philosophy. This divergence reflected deeper differences in leadership priorities. American commanders viewed pilot survivability as essential to sustained air superiority. Aircraft were designed with maintenance, reliability, and crew endurance in mind. If a system reduced fatigue or preserved pilot effectiveness, it was worth the added complexity. German leadership, by contrast, faced mounting constraints, fuel shortages, bombing damage of factories, and the loss of experienced engineers limited innovation. Designs emphasized performance gains, speed, climb, armament, often at the expense of pilot comfort. There was little room for systemic redesign as the war turned against them. The result was not a failure of skill, but of capacity. Germany could not adapt at the pace required by a high-altitude, long-duration air war. Angle 6. Psychological weight of endurance. Beyond technology and leadership lay psychology. Pilots who trusted their equipment flew differently. American pilots knew they could remain at altitude without immediate physical collapse. That confidence allowed patience, coordination, and tactical discipline. German pilots increasingly flew under strain, physical and mental. Each mission demanded endurance beyond what their equipment reliably supported. Fatigue accumulated. Confidence eroded. In aerial warfare, morale and stamina were inseparable. The side that could stay longer, think clearer, and return day after day held a decisive advantage. By early 1944, that advantage had shifted unmistakably toward the United States, setting the stage for confrontations where endurance itself became the deciding factor. Those confrontations would soon reach a breaking point, during winter missions that pushed both machines and men to their absolute limits. By the winter of 1943 to 1944, the air war over Europe had entered its most punishing phase. American bomber formations now penetrated deeper into Germany with regularity. Targets once considered unreachable, aircraft factories, ball bearing plants, fuel refineries, were struck again and again. These missions unfolded at altitudes between 25 and 30,000 feet, where cold was constant and merciless. On interception days, German pilots rose before dawn. Weather briefings spoke of clear skies above thick cloud layers, a sign that bombers would fly high. Engines were started in freezing air. Oxygen systems were checked carefully, knowing that a malfunction at altitude could be fatal. Climbs were brutal. Messerschmitts and Focke-Wulf strained upward, engines roaring as pilots fought gravity in thinning air. Within minutes, cold crept into gloves and boots. Breath condensed inside masks. Instruments responded sluggishly. When contact was made, the contrast became unmistakable. American fighters, P-47s and increasingly P-51 Mustangs, were already in position. They flew smoothly, maintaining altitude without urgency. Pilots remained with their formations for extended periods, escorting bombers far beyond previous limits. Heated cockpits and clothing did not eliminate discomfort, but they delayed its effects long enough to matter. German pilots, by contrast, often faced a narrowing window. Time at altitude was measured not just in fuel, but in physical tolerance. Prolonged exposure dulled reactions. Hands stiffened. Fatigue set in rapidly, sometimes forcing pilots to disengage earlier than planned. Winter amplified every weakness. Frozen condensation could lock oxygen regulators. Canopies iced over. Even minor equipment failures became life-threatening at altitude. American systems, supported by extensive maintenance and logistics, proved more resilient under these conditions. Engagement stretched longer. Escorts no longer peeled away. Bombers pressed on under constant protection. For the first time, German pilots found themselves fighting not only superior numbers, but opponents who could simply remain in the fight longer. Endurance became a weapon, quiet, relentless, and decisive. As these winter missions accumulated, the Luftwaffe's ability to contest the skies began to fracture, setting the stage for a shift that would redefine air superiority over Europe. That shift would soon become undeniable, as sustained losses and exhaustion forced a reckoning no amount of bravery could reverse. The winter of 1944 marked a turning point that few German pilots could ignore. By now, U.S. fighter escorts had established a consistent presence over German skies, operating at altitudes and durations that the Luftwaffe struggled to match. Each mission exposed structural weaknesses in Germany's air strategy, amplified by the relentless cold and extended engagements. On a January morning, a formation of B-17s from the 8th Air Force climbed toward the Ruhr Valley. P-51 Mustangs flanked the bombers, their pilots alert, cockpit heaters on, oxygen steady. German interceptors scrambled from nearby airfields, climbing into frigid skies. The chase began, but the odds were already stacked. The Americans were prepared for the extreme. The Germans, despite skill and courage, were physically taxed within minutes. Combat unfolded in long, measured exchanges. American pilots could maintain altitude, monitor multiple threats, and coordinate with each other with clarity that only steady physical condition allows. German pilots, by contrast, found fingers stiff on triggers, vision narrowing behind frosted canopies, and judgment clouded by fatigue and oxygen deprivation. Even when the German fighters closed the distance, they could not sustain the pressure for long. Many were forced to break off before inflicting serious damage. This attrition was cumulative. Over weeks, mission after mission, German units lost pilots not only to combat, but to exhaustion, frostbite, and the mental strain of repeated high-altitude sorties. Training replacements could not keep pace with the demands of modern aerial warfare. Even experienced aces admitted that survival increasingly depended on physical endurance as much as tactical skill. The strategic outcome was clear. U.S. Air Forces, leveraging heated cockpits, advanced oxygen systems, and rigorous training, maintained operational superiority. Bombers reached targets consistently, escorted by fighters who were alert, capable, and less prone to error. German attacks became sporadic, less coordinated, and increasingly costly. Missions that would have once been contested now passed with minimal opposition. This turning point was more than technological. It was systemic. Equipment, logistics, medical preparation, and doctrine combined into a sustainable advantage. Endurance had become a weapon, one invisible on the battlefield, but decisive in every encounter. By midwinter 1944, the Luftwaffe's inability to match this endurance directly contributed to the collapse of German air defenses over critical industrial regions. The psychological impact on German pilots was profound. Facing opponents who could operate comfortably at altitudes that punished their own forces, morale eroded alongside physical capability. Heroism alone could no longer compensate for systemic disadvantages. The United States had demonstrated that seemingly minor technological innovations, cockpit heating, insulated gear, reliable oxygen, could translate into strategic dominance. The air war had entered a new phase, one in which human limitations and machine design intertwined, determining victory long before the first shot was fired. With air superiority increasingly assured, the consequences for Germany's war effort would soon be unavoidable, setting the stage for losses that would reshape the European conflict. The winter of 1944 left a clear record in both mission reports and personal accounts. American aircrews had achieved a level of operational consistency that German pilots could scarcely match. Bomber formations, once at the mercy of enemy interceptors, now reached targets with markedly reduced losses. Escort fighters, maintained at full alertness by heated cockpits and advanced oxygen systems, allowed long-range strikes into the industrial heart of Germany with unprecedented reliability. Statistical evidence illustrates the impact. The 8th Air Force reported that bomber loss rates over German territory declined steadily as the effectiveness of P-51 and P-47 escorts increased. Missions deep into the Ruhr, the Rhineland, and even Berlin faced fewer interruptions from Luftwaffe attacks. Pilots returning from these sorties consistently cited a stark difference in how American and German aircraft endured the cold at altitude. The difference was not glamorous, but tangible. Fewer fatigued crews, fewer aborts, and a higher percentage of bombs reaching their intended targets. German air units, in contrast, struggled to maintain strength. Fuel shortages, increasingly damaged infrastructure, and attrition among experienced pilots compounded the physical difficulties of winter combat. Luftwaffe formations could not sustain prolonged high-altitude engagements, forcing commanders to limit sorties or risk catastrophic losses. Replacement pilots often lacked the conditioning, training, or exposure necessary for effective performance at extreme altitudes. The operational tempo slowed, and a growing gap between capability and expectation became evident. The consequences extended beyond numbers. German pilots reported the psychological strain of facing opponents who appeared impervious to the environmental extremes that punished them. This shock eroded confidence. Small tactical disadvantages compounded as engagements prolonged. Decisions in the cockpit became increasingly reactive, constrained by the limits of human endurance rather than purely by strategy or skill. The Luftwaffe's inability to respond effectively at altitude foreshadowed a broader shift in the air war. Even at a micro level, this technological and physiological edge altered outcomes. Dogfights that might have been evenly contested at lower altitudes tipped toward the Americans. Interceptions were often too late or ineffective because fatigued German pilots could not sustain climbing and positioning long enough to achieve tactical advantage. Each missed opportunity compounded the strategic picture. Industrial targets remained under relentless assault, aircraft losses mounted, and morale among German air crews deteriorated. These immediate results set the stage for the long-term consequences that would ultimately reshape the European air war. By the spring of 1944, the advantages gained through high-altitude endurance had become undeniable. American fighter escorts had shifted the balance of power in the European air war. Strategic bombing campaigns, once vulnerable to interception, were now executed with precision and consistency. Industrial regions critical to Germany's war effort, the Ruhr, the Rhineland, and parts of Silesia, experienced sustained attacks that strained production, logistics, and morale. The Luftwaffe, already facing shortages in fuel and trained pilots, could not recover. Veteran airmen had been lost to attrition. Replacements were less experienced and ill-prepared for prolonged high-altitude combat. Equipment limitations further compounded the problem. Aircraft without adequate heating or oxygen support could not maintain station with the Americans, reducing interception efficiency. As a result, German air strategy increasingly relied on short, opportunistic attacks rather than coordinated, sustained engagements. This reactive posture left key industrial centers exposed and accelerated the erosion of Germany's wartime production. The lessons extended beyond immediate tactical outcomes. The United States demonstrated that seemingly minor innovations, cockpit heating, reliable oxygen systems, insulated flight suits, could have profound operational effects when combined with comprehensive doctrine, training, and logistics. These advantages were not flashy or dramatic, but cumulative. They preserved pilot effectiveness, maintained morale, and allowed sustained pressure against an enemy increasingly worn down by the environment itself. In subsequent missions, the psychological effect became as significant as the physical one. German pilots reported not only exhaustion, but a growing sense of inevitability in facing American formations at extreme altitudes. Fatigue and environmental strain amplified the fear of engagement, reducing the willingness of Luftwaffe pilots to commit fully and reinforcing the operational edge that U.S. forces now held. The strategic consequences were measurable. By mid-1944, bomber losses had decreased markedly, allowing deeper penetration into Germany's industrial regions. Air superiority enabled subsequent operations, including the D-Day invasion, by limiting German capacity to disrupt Allied movements from the air. The endurance advantage also influenced post-war aviation design. Future aircraft incorporated pilot comfort, environmental control, and sustained operational capability as core considerations. Ultimately, the American mastery of high-altitude flight exemplified a shift in warfare. Victory was no longer determined solely by speed, firepower, or courage. It also depended on the integration of technology, human physiology, and operational planning. Pilots who could survive, think clearly, and fight longer were a decisive weapon in their own right. This convergence of engineering, medicine, and doctrine had transformed the skies over Europe and set a new standard for aerial combat in the modern era. The story of high-altitude combat over Europe is a reminder that war is fought not only with weapons, but with human endurance, ingenuity, and foresight. What may seem a small advantage, heated cockpits, reliable oxygen, insulated gloves, proved decisive when applied systematically. It allowed American pilots to function at altitudes where the Luftwaffe struggled to survive, turning environmental hardship into a silent weapon. Technology, in this case, was inseparable from human capability. The ability to endure cold, maintain concentration, and operate effectively for hours in thin air transformed routine missions into strategic victories. American innovation did not create spectacle, nor did it rely on luck. It relied on careful study of physiology, climate, and the realities of prolonged aerial warfare. Every design choice, from heated controls to insulated flight suits, was an investment in sustained operational superiority. For German pilots, the shock of encountering opponents who could remain calm, alert, and functional at extreme altitude was both immediate and enduring. It highlighted the limits of physical endurance, the consequences of resource constraints, and the importance of preparation in modern war. Morale, as much as machinery, was tested and sometimes broken by this quiet yet relentless advantage. This episode also illustrates a broader truth in warfare. Small advantages, when multiplied across men, machines, and doctrine, can reshape entire campaigns. The endurance and preparation of American pilots contributed to air supremacy, which in turn facilitated bombing, invasion, and the eventual collapse of enemy resistance. In the cold skies above Germany, a lesson was written not in dramatic dogfights alone, but in the measured, unyielding application of science and strategy. Comfort became combat power. Survival became advantage. And in that intersection of human and machine, the outcome of the air war, and ultimately the broader conflict, was quietly decided. In the silence of frozen altitudes, history itself took shape,